Okay, so let's have a look at the 2020 Higher Level Leaving Cert Maths Paper 1, question 8. So we have a rectangle and it's inscribed in a circle of radius 5 units with centre 0, 0. Let R, which is x, y, where x and y are real, be the vertex of the rectangle, so that's here, and that's in the first quadrant. Let theta be the angle between OR and the positive x-axis, so this is theta here, and theta is somewhere between 0 and 90 degrees, pi over 2. The point xy can be written as a cos theta plus b sin theta, where a and b are real. Find the values of a and b. Okay, so what we're going to do here is just take a look at this triangle here, and we're going to look at the sine and cos of theta. So if we take the sine of theta here, it's just going to be y over 5. And the reason for that is this distance here is our y coordinate, if you like, so this is going to be y, and this distance here is going to be x, so this is x here. So that's why we have the sine is going to be opposite over hypotenuse, and the cosine then is going to be cosine of theta is going to be x over 5. Now if the sine of theta is y over 5, that just gives us 5 sine theta is equal to y, and similarly down here, if cos of theta is x over 5, then 5 cos theta is going to be x. So we've written x and y in the form a cos theta, b sin theta, and that just gives us our answers then. So a is going to be 5 and b is equal to 5. Okay, so that's it for part A1. Let's have a look at part 2. So we have to show that a of theta, the area of the triangle measured in square units, can be written as 50 sine 2 theta. Okay, so let's look at our rectangle. Our rectangle is going to be, the area of our rectangle is just going to be length times width. So if we have another look at our rectangle, up here we have our x out as far as here. If we double it, that will give us the width of our rectangle. But we know that x is 5 cos theta, so double that, you get 10 cos theta. So our width here is going to be 10 cos theta. Similarly with the if we double this distance here, if we double y, we'll get 10 sine theta. So we've got to multiply 10 cos theta by 10 sine theta to find the area of this rectangle. So let's have a look at that. Okay, so our area then is just going to be equal to 10 cos theta times 10 sine theta. So that gives us 100 cosine theta sine theta. Now we've got to write it like this. We want 50 in there somewhere. We want 50 and we want sine 2 theta. This is going to be 50 times 2 cos theta sine theta. Now the reason I put the 2 in here is because I know from my trig identities in my maths tables that I can convert this. So let's do that. So we have 50, and that's just going to be, what I'm actually going to do is use this identity here. I'm going to say that 2 sine A cos B is equal to sine of A plus B plus sine A minus B. So that's in your maths tables. So we have this here effectively. We have 2 sine A cos B. So we have 2 sine theta cos theta. So A and B are both theta if you like. That just means that this is going to convert to sine A plus B. So that's going to be sine theta plus theta, which is sine 2 theta, plus sine A minus B. So theta minus theta is just 0. So if we have a look at that, then we end up with sine 2 theta. 50 sine 2 theta, because the sine of 0 here, this bit here, sine of 0 is just going to be 0. So that's it really, just to write it the way they want it. Then we have a of theta is equal to 50 sine 2 theta. 50 sine 2 theta. Okay, so that's it for part 2. Let's have a look at part 3. Use calculus to show that the rectangle with maximum area is a square. So let's have a look at our area formula. Our area formula now is A is equal to 50 sine 2 theta. So we want to maximize that, and the way we do that is we first differentiate. So we want to differentiate A with respect to theta, so that's going to give us 50. Now if we differentiate sine of anything, we get cos of the anything, so it's going to be cos of 2 theta. But because it's not a sine of theta here, it's sine 2 theta, we must use the chain rule and differentiate the 2 theta. So that means we end up with 2. So I'm going to put the 2 here and multiply. So that just gives us 100 cos 2 theta. Now what we need to do next is let that equal to 0. So we've got 100 cos 2 theta. Let that equal to 0. So that gives us cos 2 theta equal to 0, divide across by 100. Now if cos 2 theta is equal to 0, we've got to work out what 2 theta is. So we do cos inverse of 0 if you like. So what we end up with is 2 theta is equal to our angle, which in this case is going to be 90 degrees, pi over 2. So in other words, the cos of pi over 2 will give us 0. The cos of pi over 2 will give us 0. Okay, so we have 2 theta here, so what we've got to do now is just work out what theta is. So theta is going to be divided across by 2, and we get pi over 4. So theta is 45 degrees, or pi over 4. Now what is theta? Let's just have a look back up here at our diagram. Theta is this angle here. So we know that that's going to be 45 degrees. Now, how are we going to work out that this is actually a square when the area is maximized? Well, we know that x is 5 cos theta, and we know that y is 5 sin theta. So if x and y are both the same values, that means double x and double y are going to be the same values, which means that this thing is going to be a square. So I'm going to put theta in here, theta in here. If I get the same answer in both cases, then this will turn out to be a square. So let's do that. Okay, so we need to we know that y is equal to 5 sin theta. So that gives us 5 sine pi over 4. That gives us 5 times 1 over root 2. The sine of pi over 4 is 1 over root 2, so we just end up with 5 over root 2. Similarly here with x is equal to 5 cos theta. So that gives us 5 cos pi over 4. So that gives us 5 over root 2 as well. The cosine of pi over 4 is 1 over root 2. So in both cases we end up with 5 over root 2. Okay, so we have x and y, so we just need to double those. So twice 5 over root 2 will give us our length, and twice 5 over root 2 here will give us our width, if you like. So we have our length is going to be 10 over root 2, which is 5 root 2. And similarly with our width here, that's going to be 5 root 2 as well. So therefore I can say the area is maximized. The area is maximized when theta is pi over 4. The area is maximized when theta is pi over 4 and the shape is a square. Okay, so let's have a look at the next section. Okay, so what we've got to do next is find this maximum area. So we know that the area is going to be 50 sine 2 theta. So we need 50 sine 2 times pi over 4. That just gives us 50 of the sine of pi over 2, and that's just going to be 50 units squared. Because the sine of pi over 2, the sine of 90 degrees, is 1. So 1 times 50 is 50. That's it for part 4. Let's have a look at part B. So we have a person who is 2 meters tall is walking towards a street light of height 5 meters. So this is our street light here at a speed of 1.5 meters per second. So he's moving in this direction at a speed of 1.5 meters per second. Find the rate in meters per second at which the length of the person's shadow x, so this is his shadow here, x cast by the street light is changing. So his shadow is going to change as he moves in this way. His shadow is actually going to get shorter. L is going to get shorter. This distance here is going to get shorter here as well. So let's just write out what we need. Find the rate in meters per second at which the length of the person's shadow x is changing. The rate at which his shadow is changing. So what we're actually looking for there is how x is changing, dx, with respect to time. So that's what we want to find out. So let's put the dx here. That's going to be over something. We've got to multiply that by something over dt. We just got to figure out what to put here and here. We need to put the same thing in those two positions. So the other thing that's going to change here is L. This thing here is going to change. And we are given some information about that in the question. We're told here that the speed of the person walking towards the street light is 1.5 meters per second. In other words, L is changing. This distance here is changing at a rate of 1.5 meters per second. In other words, we have dl dt. And that's going to be 1.5 meters per second. So we have dl dt. So that means if we put dl here, we would have this this part of our equation here. So let's put the dl down here as well so that it cancels, if you like, so that we end up with dx dt. So we have this here. Now all we got to do is work out this one here, dx dl. So how is x changing with respect to L? So we got to form an equation with x and L in it. Now the other thing you probably should have noticed here is that we have two triangles, two similar triangles. So we have this big one here, and we have this little one inside it here. And this is going to be parallel to this, so therefore we can look at the two similar triangles and look at the theorem that says the sides are going to be in proportion. So let's form an equation then with L and x in it. If we can do that, we can get x on its own and work out then dx with respect to L. So let's work through that. So we can see, we can use the two numbers we have anyway. We've got 5 over 2. So this side in the large triangle divided by its corresponding side in the small triangle is going to be equal to this side in the big triangle. So that's just L plus x divided by its corresponding side in the small triangle, which is just x. So now we have an equation with just x and L in it. So we can get x on its own here. So the first thing I'm going to do here is just cross multiply. So I end up with 5x is equal to 2L plus 2x. Let's bring the x's over to one side. So that'll give us 3x is equal to 2L. And then finally we have x is equal to, divide by 3, 2 over 3L. Now what I need is dx dl. I need to differentiate x with respect to L. So I'm going to do dx dl here. So that'll just give me 2/3. So now I have dxdl, I have dl dt, so I can work this out up here. So dxdl is 2/3. I'm going to multiply that by 1.5, which is 3 over 2. Leave it as a fraction. 3 over 2, and you can see here that if you multiply 2/3 by 3 over 2, you'll get 1. So, and remember that's meters per second. What did we actually find here? We found how the shadow here is changing with respect to time. So it's changing at a rate of 1 meter per second. It's actually getting smaller. You could say it's minus 1 meter per second. So it's actually getting smaller as the person walks towards the street light here. So that's it. That's all we had to find. I think find the rate in meters per second at which the length of the person's shadow cast by the street light is changing, and that's what we found. And that's it for this particular video.